How does Java reflection work under the hood? When you compile a Java program, the class files don't just contain bytecode. They also contain metadata, things like field names, method signatures, constructor definitions, and annotations. When the JVM loads a class, it keeps this metadata in its internal structures. The reflection API in Java, built on top of the class object, lets you access that metadata at runtime. For example, you can ask a class what methods it has, get references to those methods, and even call them. The method, field, and constructor classes are just wrappers around the metadata stored inside the JVM. When you call something like method, invoke, the JVM goes through several steps. It validates the parameters, boxes or unboxes primitives if necessary, and then delegates to a native call that actually runs the method bytecode. Finally, it returns the result back to you. All of this adds extra overhead, which makes reflection slower than calling a method directly. The JVM has optimizations to reduce this overhead. The first few times you invoke a method reflectively, it might use a generic slow path. But if you invoke the same method many times, the JVM generates a faster accessor behind the scenes. Modern Java versions also use method handles and invoke a dynamic to make reflection-heavy frameworks perform better. So, under the hood, reflection works by exposing the metadata that the JVM already has, and by letting you manipulate and invoke code dynamically. It's flexible and powerful, but it comes with performance costs, which is why it should be used carefully. If you found this helpful, please like the video and subscribe for more deep dives into Java and programming concepts.